Alright, now we have topic 6.3, Squares and Rhombi. We will be defining both the term the rhombus and a square. We will look at both of these combined in this lesson. We will look at their definitions and their properties. We will look at drawing a picture just like we did before. And we will use the properties to solve problems relating to each. Alright, so let's run through our notes real quickly. Here we have our rhombus. That's the first thing that we are going to be dealing with. We have the rhombus and our definition, a parallelogram with four congruent sides. That's all there is to it. So a sketch, if I sketch it, let's go ahead and let's add a different color in here just so that way we can kind of see it. Four congruent sides. They're all going to be congruent. Alright. So, in addition to all the properties of parallelogram, rhombus has two additional properties. So, here we go. Let's start with our opposite sides are parallel. Draw these in here. Alright. Opposite sides are congruent. Let's grab a color that's going to show up. Now, the thing with these opposite sides are congruent is we know we have four congruent sides. Let's add this color up here. That way this is what we're referring to. So 2 and 6, they actually go together. So, not just are our opposite sides congruent, but all sides are congruent. I'm going to fix this thing here. It kind of looks like there's two. Alright. Opposite angles are still congruent. So there's a 1 and a 1. And there's 2. And there's 2. Alright. Consecutive angles are supplementary. Let's put this right down here. We've got our lovely green. These two together, so you add them together, they equal 180. Alright, let's see, that'll blend in nicely. Okay, let's see what I was shooting for here. Our diagonals bisect each other, but it's not the definition of a rectangle. So, these two will be congruent, and then these two will also be congruent, but only with each other. Got a little carried away with that mark there. See if I can fix it now. I'm just paying too much attention to it. Alright, here we go. So we've got our number 6, 4 congruent sides already marked. Diagonals. Our diagonals are perpendicular. So, if our diagonals are perpendicular, not going to do that in green here. Here we go. Our diagonals are perpendicular. Means this forms a right angle. That forms a right angle. That forms a right angle. And so does this one. So we have 4 right angles, which a right angle is 90 degrees. And our diagonals, here's another big key. Find a color for it. Our diagonals bisect our opposite angles. So, by looking at that, if it bisects this angle, both of those are the same, as well as these two. Individually, they are the same. And we're going to really have to up this here. These will be the 3s. We can really get carried away with some marks here. So now all the 3s are congruent. Oh, now we need fours. 1, 2, 3. Ooh, getting a little out there. 4. And we got a 1, 2, 3, 4. Now, I'm not going to expect you to draw all these and remember it with the colors. Because, I mean, quite frankly, unless you have map colors, this would be very difficult to do. But you can always check back here to see the image. Big key thing is being able to look at these properties and knowing what we have. Alright, so let's look at an example. Example 1, if the measure of angle RST, so this whole thing right here, every bit of that is 67. Find RSW. Well, we know this is bisects it, so that means it cuts it in half. If it cuts it in half, we can say, well, that's 1/2 of 67. So the measure of angle RSW equals 1/2 of 67, or 33.5 degrees. What's it asking us for? The measure of RSW, and we have accomplished it. Alright. Find the measure of SVT. So it wants us to find this if STV, this whole thing over here is, go ahead and put this, 135. Going back to our properties, what do we have right here? Our green one. Let's look here. Number 4, consecutive angles are supplementary. Do we have consecutive angles? Can we say that these angles right here are consecutive, that they together equal 180? Yes. But that's both of these. That's both of these angles right here together. We know one of them, but what do we know about this one? It equals that. I'm going to substitute in a variable. I'm going to say this is x. So I can now say 2 of my x's. It's a pretty bad x. Let's try that again. 2x, that's not much better. 2x plus, because we can add them together, plus 135 equals 180. 2x plus 135 equals 180. 2x, I'm going to subtract my 135 minus 135 equals a 45. Okay, so now divide that by 2. And you will get x, which is what we substituted in any normal variable. We did not have to find x. We could have called it a, we could have called it b, z, whatever we wanted to. But x now equals 22.5. Now, it's asking for the measure. So, this is our x. We need to go ahead and say the measure of angle SVT, because that's what it wants us to find, equals, and now it happens to be exactly what we have here, 22.5 degrees. And there's our answer. Alright, let's move along to our next page. We have example 3. It tells us if the measure of SWT is 2x plus 8, find x. Well, what do we know with a rhombus that each of these are? These are perpendicular, so they're all right angles. They all equal 90. So we know that a 2x plus an 8 equals 90. 2x equals 82. And so that leaves us with x divided by 2 divided by 2. X, and that's what we're after right here. X equals 41. So it tells us to find x. Here it is. X equals 41. Moving to example 4. What is the value of x if? All right, let's see what it gives us here. MRV. Not M. WRV. 5x plus 5. Okay, we know that. And WRS is a 7x minus 19. Go back to your first page. Let's see if I can make that look a little bit better. There's 7x minus 19. A little bit better. Go back to your first page. Tell me what you discover about these two angles right here. This angle is going to be congruent to this angle. If they're congruent, they are equal. The only reason that we can say that is this right here. It tells us RSTV. Ooh, terrible line. Let's try that again. RSTV is a rhombus. Now that we know that it is a rhombus, we now know that these two are congruent. If it told us that it's a rectangle, then what do we know? Well, then we know that it adds up to 90. But it tells us it's a rhombus. They're equal. So you can say 7x minus 19 equals 5x plus 5. Minus 5x plus a 19 minus 5x plus a 19. 2x equals 24. X equals 12. What's it asking for? What is the value of x? Our value of x is 12. Alright, moving along. Example 5. We have A through E. In rhombus. Okay, we know it's a rhombus. So we know that we can look back at our notes. First page of it, we can look at the picture and we know everything about it. We know all the properties. DM, the whole length. Side DM, let's get a little bit brighter color here. DM, this whole thing right here is 24. What do we know about this then? We know this is 12, and this is 12. Alright? The measure of angle LDO, is 43 degrees. So I'll put this in here and say this is 43 degrees. And DL, the length of this up here, is 13. Find each of the following. OM. Hey, we already wrote that down. OM. Done. We wrote that down already. DOL. Well, this is a rhombus. So, what do we know about all of these interiors? You can draw the diamond around it. If you draw the diamond, that means a DO and an L equals 90 degrees. So we have a 90 degrees right here. DLO. Well, we've got two sides of a triangle. We've got a 90 plus a 43. A 133. And we need another side over here, another angle that is going to give us, plus whatever we don't know, is going to give us 180. Okay, so a little bit of math on that. 180 minus 33. 47. So looking for the measure of the angle, keep it in degrees. Measure of DML. The measure of DML. Well, with what we determined in the rhombus before, see if I can find a color for it, is we have these, which are all congruent, every one of these. So, if these are congruent, DML would then equal the same thing. That is, DML would equal the same thing is what we have here for, would it give us? LDO, 43. 43 degrees. And lastly, it asks us for DP. DP. Go back to the rhombus. Part of it, let's say property number 6. 4 congruent sides. All of them are congruent. They're all 13. You can say this is 13, this is 13, this is 13. All congruent. So that wraps us up with our rhombus terminology. Next we have our square. So let's go ahead and move on real quickly to our square definition and sketch a parallelogram with 4 congruent sides and 4 right angles. So it's kind of a combination of our rectangle, which has 4 right angles, and our rhombus, which has 4 congruent sides. Let's grab a quick sketch here. The main thing that it just told us is we have 4 right angles, and we have 4 congruent sides. That's the main bit of information that it just gave us. Alright, because a square is a special parallelogram, it has all of the properties of a parallelogram in addition to those of a rectangle and a rhombus. Like I just said, that's a combination of the two. So let's look at our properties. Opposite sides are parallel. So let's go ahead and mark it in here. If you take your time to do this, you can look back on it on any assignment. You'll be able to quickly reference and determine what sides are parallel, congruent, so on and so forth. Help you tremendously with your assignments. Alright, that's done. Opposite sides are congruent, but we know a little bit more about that, don't we? Our opposite sides are congruent, but we can also go down here and say we have, here we go, number 8, 4 congruent sides. So these kind of interconnect. We can say here, 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 and here. Alright. Let's see what else we can determine about this. Opposite angles are congruent. Well, yes, and then there's something else that goes along with this. We have 4 right angles. Now we didn't mark this in the rectangle this way, but all we have to do is simply put just what we see right here. There we go. That should show us that our opposite angles are congruent, but all angles are congruent. They are all what? They are all 90 degrees. Consecutive angles are supplementary. That almost should be a given at that point. A 90 and a 90 is going to equal 180. Alright. And let's see, I'm going to go ahead and mark this. Diagonals bisect each other, but that can also goes with this, the part of our rectangle of our diagonals are all congruent. So we can put 2 lines on this one and this one, but also we can come around and we can put, we've got 2 lines here and 2 lines here. All of these have been bisected and all these segments are congruent. Diagonals are perpendicular. They are perpendicular. So we can come over here and we can make our diamond here in the middle of it. And that shows that these are 90. Now if this bisects it, what do we go ahead and let's go ahead and look at this. If this gets bisected directly, which we're going to comment on right here, diagonals bisect our opposite angles. So what do we know about this one? If it's bisected, a 90 divided by 2, it's a 45. This is a 45. And we can put that all the way around. These are all 45-degree angles. The bisection portion of it, the angles together are 90. So let's take that and let's look through a couple of examples real quickly. Math, M-A-T-H, math is a square. Alright, if M-A is 8, then A-T, I can do this, everything's 8. M-A is 8, A-T is also 8. Alright, find the measure of H, S, T. HST. Well, if we come over here and we draw our diamond here in the middle, we know that that is 90 degrees. MAT, MAT. We also know that these are all 90s. We know this. So MAT is 90 degrees. If HS is equal to 2, let me go ahead and grab another color for this here. HS is equal to 2. Then HA, which if this bisects it, that means this is also, this side right here is also 2. And if that's 2, we have a 2 and a 2, then HA overall is a 4. MT, hey, what do you know? These are all going to be the same. MT is also 4. Squares are very easy to work with when it comes to this because they are all, everything is congruent. What you have on one side you will have on the other, and everything's in nice squared fashion. 90 degrees, 45 degrees. Alright, let's go ahead real quickly and let's look at our last example. It says use square ABCD, so it told us it's a square and we know all the properties to it now. And the given information to find each. Alright, if, let's find a good color for it. If AED, well, what do we know about these to begin with? Let me go ahead and grab this for that. What do we know? AED, we know it equals 90. It tells us that it's 5x plus 5. So 5x plus 5. But we know it equals 90, so that's 5x plus 5, we know it equals 90. Minus 5, minus 5. 5x equals 85. X at that point then equals 17. So x equals 17. If BAC, well, let's go back and let's make sure that we know what we know, which you should know. If you don't know, I've used a lot of no's. These are all 90. That means if we cut it in half, because these bisect these angles, this is a 45 degrees. So let's see what it's going to try to tell us. BAC is 5x, but we know better than that. We know that it is 90. So our 5x really equals, not 90, I'm sorry, 45. Almost got a little carried away there. So our x is equal to 9 in this instance. Alright, so that takes care of topic 6.3, squares and rhombi.